high magnetic field reading, such as 40 milligauss, near a ceiling often indicates an issue with electrical wiring. Several potential causes exist. Firstly, consider a faulty neutral connection. An improperly connected neutral wire within a lighting circuit can cause current to flow through the grounding wire. This unintended current flow will generate a magnetic field. Secondly, examine three-way switch circuits. In a three-way switch setup, using only two wires, called travelers, instead of the required three, which includes the travelers and a common wire, can lead to induced currents and subsequent magnetic fields. Thirdly, investigate the quality of the grounding system. Inadequate grounding can allow stray currents to flow through the ground, again producing magnetic fields. Fourthly, check for ground fault loops. If a ground fault occurs and the grounding wire is not properly connected, it can create a loop that generates a magnetic field. To address this situation effectively, it's essential to contact qualified electricians who understand electromagnetic fields and electrical troubleshooting. When contacting electricians, explain the situation thoroughly. Provide specific details about the measurements taken, including the location where the high magnetic field was detected. Request a comprehensive inspection of the entire electrical system. Emphasize the importance of focusing on lighting circuits and the grounding system during the inspection. If a standard electrician is unable to identify or resolve the issue, it might be beneficial to consult with a certified electromagnetic field, or EMF, specialist. These specialists possess specialized knowledge and equipment to diagnose and mitigate complex EMF-related problems. To further elaborate on possible causes, let's consider the principles behind electrical wiring and grounding. In a properly functioning electrical system, current flows from the power source through the appliance or load and back to the source via the neutral wire. The grounding wire provides a safety path for current in case of a fault, preventing electrical shock. When the neutral wire is improperly connected or carrying unintended current, it disrupts this balanced flow, leading to magnetic field generation. In a three-way switch circuit, the common wire should carry the current from the power source to the lights, and the two traveler wires allow the switches to control the light from two different locations. If the wiring is incorrect, current can flow through unintended paths, creating magnetic fields. Regarding grounding, a properly grounded system ensures that any fault current has a low resistance path back to the source, tripping the circuit breaker and disconnecting the power. If the grounding is inadequate, fault current may flow through other paths, such as water pipes or building structures, creating magnetic fields. Ground fault loops occur when there are multiple ground connections with slightly different potentials, causing current to flow between them and generating a magnetic field. Remember that all electrical circuits produce some level of magnetic field, but unusually high readings indicate a problem that needs to be addressed. Magnetic fields are measured in units called milligauss, abbreviated mg. While there are no universally agreed upon safe levels for magnetic fields, consistently high readings may warrant further investigation and remediation. In addition to the potential causes mentioned, other factors can contribute to high magnetic field readings, such as proximity to high current appliances or equipment, electromagnetic interference from external sources, or improperly shielded electrical panels. Therefore, a thorough inspection of the entire electrical system is crucial for accurate diagnosis and effective resolution. Furthermore, it's important to distinguish between magnetic fields and electric fields. Magnetic fields are produced by moving electric charges, while electric fields are produced by stationary charges. Both types of fields can be present around electrical wiring and equipment, but they are measured and addressed differently. To accurately assess magnetic field levels, use a calibrated Gauss meter. Take multiple measurements at different locations and times to get a comprehensive understanding of the magnetic field distribution. When contacting electricians, be prepared to provide detailed information about the problem, including the specific location of the high magnetic field reading, the time of day when the reading was taken, and any recent electrical work that has been done. The more information you can provide, the better equipped the electrician will be to diagnose and resolve the issue. In conclusion, high magnetic field readings in homes can be caused by a variety of factors, including faulty neutral connections, three-way switch wiring issues, poor-grounding, and ground fault loops. Addressing these issues requires a thorough inspection of the electrical system by a qualified electrician or EMF specialist. By understanding the potential causes and taking appropriate action, you can create a safer and healthier living environment.